Now let's go back to the oceans again. This time, instead of a nice warm wind blowing, we're going to blow a cold wind over the ocean. So here it is. Now what do you think happens here? Well, here the oxygen 18 is just a little bit heavier than the oxygen 16. So it finds it more difficult to get itself out of the ocean and up into the cloud. So here you're going to see, nope, doesn't make it. So this cloud, created by colder winds, this cloud is going to be higher in oxygen 16. It's going to be higher in the lighter oxygen. So whenever this one goes over the ice cap, we find, hey presto, that we've now got a band of oxygen 18. So how does this work? How can we use that to look at the history of temperature? Well, actually we can pick up the temperature of summer and winter. So you see, in summertime we're going to be dealing with warm clouds. So in summertime we have a mix of heavy water and light water. In wintertime, with more cooler clouds, we're going to have a lot less heavy water. Most of this is going to be light water. So back and forth, you're taking a core, you're drilling a core into the ice, and this is an example of that core. So this here, these top two bands might be 2009, and these bottom next two might be 2008, 2007, 2006. Okay, so this is how we can go back through time. Now that doesn't help us in finding out the actual temperature of the Earth. That's like tree rings. We can go back and we can find out, for example, how old the ice caps are, but that's not really interesting. There's just two ice caps on Earth, the Greenland one and the Antarctic one. So just finding out how old they are, that's not going to be so interesting. How do we use that information to actually get an idea about the temperature? Well, think about what's going on in the water. As the ice caps grow more and more, these ice caps have got a lot of the lighter water. And so the ocean water, actually, the ratio becomes less of that lighter water. So the ocean water, you see, now after all of this ice has come off, the ocean water has got a lot of oxygen 18. So the ocean is high in oxygen 18, and the ice caps are high in oxygen 16. The more ice caps there are on Earth, the more this ratio is going to be different. So if there's just a little bit of ice, well then the water here has got about the same amount of oxygen 18 as before. But as the ice caps become thicker and thicker and thicker, then the oceans become higher and higher and higher in oxygen 18. And the clouds that go, the winds that sweep the water off the ocean, those clouds become higher in oxygen 18 as well. And so, although it's true that we have bands for summer and winter, summer and winter, summer and winter, all the way through, there's going to be a difference. And that is, progressively, this is going to become more and more. The summer ones are going to get higher and higher in oxygen 18 because now they're pulling off more and more oxygen 18 off the water. Do you get it? This is a tough concept. Okay? I see everyone got it. That's great. Okay. So let's now use that. So instead of measuring temperature, what we're really measuring here is the amount of ice on Earth. And here's what we find. This is the amount of ice on Earth. So right away, we see there's it's also, you could also say that it's sea level, because of course as the ice goes up, there's going to be, the sea level is going to drop. So you're measuring both of those. What's the first thing that you notice about this? First of all, So this is a proxy measure of temperature. We're not measuring temperature directly again, we're measuring it indirectly by the amount of ice on the Earth. What do you notice first of all? You notice these spikes. These spikes are occurring regularly. You also notice the troughs. These troughs are a time of really, really cold experiences on Earth. You should also notice something else, and that is the amount of variability. You notice that for the first 10,000 years of our history, the climate varied very little. But now, whenever we go back to this part of the Ice Age, we're seeing huge changes in temperature. Okay, so this is 20,000 years ago. Check out where that is on this graph. That's just down here after we've fallen right off the bottom. It's about here. Okay, so this is 20,000 years ago, and this is North America. That is not snow. That is ice. The black dot there is Calgary. Calgary would have 1 kilometer of ice top of it. Here's some other evidence. We happen to be very close to the largest erratic. This is a boulder that is being dropped by that retreating ice sheet. And this boulder is called Okotoks. That's actually the name, Okotoks. That's the Indian name for this rock. And it's outside of Okotoks. And this is the largest erratic in the world. So you should, if you're ever going through Okotoks, this is the primary reason to visit Okotoks, is to visit this erratic. So this large piece of rock was dropped there by the retreating glacier. So again, that's the glacier. You can imagine as it's heating up the world, that over the last 20,000 years, that this large boulder was dropped. Now I want to take you back to what we were doing and to show you some of the things that happened for us. Agriculture was first developed around where you see this. Before this, everyone was hunters-gatherers. So you get up in the morning, the women would probably go off and find nuts, the men would go off with their bow and arrow and hunt antelope. Okay, so before this time, life was pretty basic. You can see here that there were some people on Earth, this is in the 1900, there were some people that were still involved in hunting-gathering lifestyle. By 1950, these are the Bushmen, Khoisan people, and they're living in Botswana, and they actually took up agriculture only in the 1950s. If we go back 13,000 years ago, we find the first people entering North America. These are the Clovis people. All of this, lots of debate going on with scientists. So this is, don't think that everything here is fixed in stone. By 13,000 years ago, the Clovis people had moved, coming in probably through the Edmonton-Calgary corridor and entering into North America. So those are the first people that entered North America. 30,000 years ago, we have the earliest cave paintings. Again, this is highly contentious. There's people that disagree strongly that this is 30,000 years old, but there we go. How do we date stuff like this? Well, stuff like the cave painting here. How does the estimate come up for 30,000 years ago? We use something called carbon-14 dating.